All right, you guys able to see my screen? Good. All right, so I got the updated computer, so it's been working a lot better today. So it's going quicker, which is good. All right, so our ultimate goal for just the first half is to be able to take a problem that has a rational exponent, which is basically just an exponent that is a fraction, and be able to write it as a radical, which is the types of problems that we've been looking at so far in chapter 6. There's one big rule that we are going to follow that connects how a rational exponent works compared to a radical. If you have a fractional exponent, so let's say I just have a number raised to 1 over the nth power, the denominator of your fractional exponent is representing the index of your root. So it's representing the degree of the root that you're taking. So if it's an a to the 1/2, a to the 1/2 is exactly identical as a square root. A to the 1/3 is exactly identical to a cube root. And then a to the 1/4 is a fourth root, so on and so forth. So we are going to practice rewriting as radicals. And then I'm going to have my power sheet handy, which I have up here on my tab. My power sheet in order to start to simplify these radicals down, if I need to. Sometimes I might not even need to, but some we might have to. So in this first example, I've got a base of 625. That would be like the a of this example I was looking at up here, and then raised to the 1/4 power. So that 4 in the denominator means that this is the fourth root of 625. So those fractional exponent denominators are going to represent the index of our problem. Now, in order to simplify that, I'm just going to head to my power sheet, and I'm going to look in this fourth column, because I'm dealing with a fourth root. I'm going to find 256. I can slide over all the way to n. The fourth root of 256 is going to be 4. So my first answer there, excuse me, I wasn't doing 256, sorry. I was doing 625, so it would be 5. The fourth root of 625 is going to equal 5. Now, I understand that you could just type that into your calculator. I'm sure you all could figure out how to do that, but it's not going to really help us get a grasp of first how to change into a radical. But then also using that power sheet, it's going to be something really beneficial to you. It's going to pay off in the long run as we start to get into logarithms in chapter 7. So logarithms are another way to do exponents, and it's going to be really beneficial to you to kind of get used to how that power sheet works, and then it'll definitely pay off in the long run as we start to look at chapter 7. Heading into part B, I've got a 12 to the 1/2 times 12 to the 1/2. So that index of 2 means I'm dealing with a square root of 12 times a square root of 12. And that's going to then equal, anytime we're multiplying a square root times itself, that's going to make the square root disappear, and we're left with 12 for our second answer. So square root of 12 are going to multiply to 12. Thirdly, I have a 12 to the 1/3 times 18 to the 1/3, which is going to be the cube root of 12 times the cube root of 18. Then when you multiply 12 and 18 together, I forgot what that was. I think it's 216. The cube root of 216. So since they both have the exact same index, I can multiply those radicands together. 12 and 18 are going to make the cube root of 216, which is going to be 6. And I'll go to my power sheet. So we had a question, what happened to these 1/2s? 1/2. So the 1/2s, what I am going to do is that 2 down in the denominator represents the index of a radical. So I'm converting from a power form to a radical. So if it's a 2 in my denominator, that means I'm dealing with a square root. So this 12 to the 1/2 becomes a square root of 12. And then this 12 to the 1/2 also becomes a square root of 12. And then anytime you multiply 2 of the exact same square roots, it's just going to equal the radicand. So we get 12 for our answer. Does that help out at all? Where am I looking? Miles? Oh, you commented? Yes. If you could turn on your video, then I could see you nodding your head too. That would be Awesome. I just want to review really quick on C. So 216, the cube root of 216, I would head to cube root on my power sheet. There's 216, and then I'm going to go back to that first column, 6. So that's how we're using this power sheet to find the cube root of 216, and we're going to get 6. So I do really challenge you, try to do these without a calculator. It is going to pay off in the long run as you get used to using that power sheet. Go ahead and check it with your calculator after, but challenge yourself to do that. So our new concept we've already kind of introduced is these rational exponents. It's any exponent that is a fraction. And our basic rule we followed from above is just kind of the start of how these rational exponents work. So if we have now a power where the fractional exponent has both a numerator greater than 1 and a denominator greater than 1, we can change it into a radical. So the same idea, that denominator becomes the index of our radical, and the power is raised to whatever the numerator is underneath your radical. So your rational exponent, so this fraction m over n, the n represents your index of your radical, and then the m is going to be the power that your base is raised to underneath the radical. Now, one little variation of this, since radicals and powers are both in the exponent part of order of operations, you can choose which way you solve these first. So if you want to take the root first, so you could take the nth root of a, and then secondly, you could raise it to the m power. So it does work either way because you're dealing at the same point on the order of operations. So if you wanted to do the power first under here and then do the root, you could do it that way, or you could do the root first and then raise it to that power. And I will show you variations of that and how you can do that when we get into the delta math especially. So we'll use that rule then to start looking at problem 2. So problem 2, we're going to take a look at 2 problems. We'll do this first one right here, and then we'll do this one just to kind of get a practice of going from a radical back to a rational exponent. So looking at A, I've got what are negative 2y to the 4/5 in radical form. So negative 2, right now, negative 2 is being raised to the power of 1. So there's nothing that's going to change with that negative 2. So negative 2 is just going to be part of my problem. It's not being raised to any power. It's being raised to a power of 1. So it's just going to stay the same. The y to the 4/5 is what I can start to change into a radical. So I'm looking at the denominator first. I see my denominator is 5. So that's going to be a 5th root. And then I'm going to have a y to the 4th underneath my radical. So that one would simplify in radical form to negative 2 times the 5th root of y to the 4th. So I'm going to check then also, I look y to the 4th. If we go back to our perfect nth roots, I don't have enough y's to take out a 5th root, so that's how I'm going to leave it. It's going to be simplified in radical form as much as it can, right there, negative 2 times the 5th root of y to the 4th. Moving on to part B. This square root has an index of 2. So that 2 is going to represent my denominator. And I have 2 separate powers in here. I have an a to the 1st power, and then I also have a b to the 3rd power. So both of those I'm going to write out as fractional exponents. I'm going to have a to the 1/2, and remember the 2 is coming from that square root, and then b is going to be raised to the 3/2. So there would be my simplified back into exponential form. So a to the 1/2 is coming from the a to the 1st, and then the square root, and then the b to the 3rd power is coming from the b to the 3rd, and then with that square root there. So just a little tricky thing, whenever you see a square root, you do have to put that 2 into the denominator on your own. It's not going to always be written there, so that you'll have to recognize that. Any questions, throw them up in the comments on that second problem, converting our radicals. All right, so everybody's doing okay. Let's head into delta math and take a peek. Okay, so we'll head into this first problem. I've got a 7x in parentheses to the 1/5 power. Because this has parentheses, this whole thing right here is going to represent my base. So 7x is my base, and then I'm raising it to the 1/5 power. So I take that 5 from the denominator, that's going to be my root. And then since both 7 and x are my base, the 7 and the x are going to go underneath the radical. So I'm looking for a radical that is a 5th root, and then with the full base of 7x inside, that is going to be, I can click it there, and it's not wanting me to do that. There we go. And there would be my 5th root of 7x. Let's see if it wants to work here. Well, that's going to be the correct answer. For some reason now it doesn't want to work. But that'll be our first type of examples that we'll see. Let's see if this one will work. All right, let's try this one. So next we have 81 to the 5/4 power into simplest radical form. So I'm going to rewrite this as a radical form. It's going to be the 4th root of 81 to the 5th. So now I'm going to check to see, can I simplify this any further? And how to simplify is, you guys still able to see mine? Good. I don't know what this, so I think my Delta Math's having some issues. So this might be our last one. We'll see here. But let's see. So we got a 4th root of 81 to the 5th. I'm going to rewrite this as the 4th root of 81 because I know that I can find the 4th root of 81. And then I'm going to take and raise this to the 5th power right there. So let's head to our power sheet. So here's how we can now simplify. So if I can simplify, I'm going to check to see if I can get an actual number. Charles, you're having some issues? Okay, so we might have a little crisis on our hands. Thank you for letting me know. But I'm going to head back to this problem, which is the 4th root of 81 and then raised to the 5th power. So recall, you can do these in any order. If you want to do the root first, figure out what that is, that's great. If you want to do the power first, you might get some bigger numbers, but that'll also work. But let's check it out here. So the 4th root of 81, here's 81. 4th root of 81 is 3. So far now I've got 3, and then I'm going to raise that 3 to the 5th power. So I'm going to go back into my column of 3, raise that to the 5th power, which is going to bring me to here, 243. So that would be my final result. Doesn't look like Delta Math's going to let me do that right now. We'll see if it allows me to put that in, 243. Doesn't seem like it's going to let me. So something with your guys' hour, I don't know what it is. 6th hour, it just doesn't work, right? Where's Charlie? This happened before, right? And then who else? Nick, you said you were having some trouble too? Dang it. Well, we're going to have to maybe just, who's this, Fearing? So we maybe have just a little unstable time here. I actually follow Delta Math on Twitter, so I'm going to go and check and see if they have an announcement. But I'm really sorry about that. If you're looking to get your work done here right away, you can keep trying it. But we're going to finish up class right there for the day. If you want to stick around, if there's any